Thank you very much. How's everyone going? Good? We having a good dev world? Yeah. Hey, excellent. All right, let's get started. Thanks so much for coming out. Can I hide the controls? There we go. Oh, yeah. Yep. So, my name's Tim Oliver, and I'm going to be talking about solving the massive app problem, rearchitecting a 5-year-old code base. Quick bit of housekeeping, I guess. Who am I? My name's Tim, although a few people here, for some communication reason, think I'm called Tom, so you can call me whatever you want. I'm a graduate of ECU, so back when AUC was fully sponsoring this thing and only university students and teachers could come, I was coming under the ECU banner. I've done 8 dev worlds, 2010 was my first, and I'm so happy to see it still going strong. This is a fantastic conference. It's empowered generations of developers, which is just so good to see. I've been doing iOS development as a hobby for 10 years now. Like the September 2008 was like my first time opening Xcode, which is just a terrifying thought to me. I feel so old now. But I've been doing full-time iOS development as my main source of income for 5 years now, which is excellent. In my free time, apart from making my own side apps, I also love open source a lot. I make a lot of view control libraries. My most popular one's now being adopted by Google in the Google Drive app, which is so awesome. But I just love just making all my controls open source as I can, just to help give back to the community. And I play video games and I do karaoke a lot. There's a few videos on YouTube that probably shouldn't be up there. So where do I work? So as you probably saw at the opening keynote, I'm working for a company called Mercari, and Mercari does not exist in Australia at all, so I wouldn't be surprised if no one's heard of it. It is a startup located in Tokyo that came into existence in 2013. So it's only a 5-year-old company, but it's been growing very, very quickly. It's a C2C marketplace, that's peer-to-peer. The idea is, I don't want to say secondhand goods exactly, but basically the main focus is if people want to sell some of their own possessions to someone else, we provide a platform that makes it very, very easy, very, very quick, and one thing that a lot of people don't even think about is we make it anonymous as well. We make it such a way that you're not sharing addresses between people. So when you sell something to someone, you don't know where they live, which is, in this day and age of privacy, is a really big win. It's been downloaded a couple times, which is really, really cool. Also kind of scary when you think about like all the potential issues that could arise. But yeah, it's been going very, very strong for us. And very recently it was considered the first unicorn startup, which if you don't know what that means the first startup company to be rated at $1 billion of value. So what do I work on specifically? I work on the Mercari's main iOS app, which is mainly iPhone, but also for iPad. This is an app that started in, I checked the headers to double check this. The app delegate.h was created in March 2013. It was, as you can probably imagine, before then it was completely Objective-C, but currently has over 30 contributors in our GitHub account. So that's been, some engineers have left, but for the most part, a lot of engineers have stayed on. So this is an app that's got 30 active contributors working on it. And it's very interesting in that we are a team of iOS engineers, but we're assigned to separate features. So I'm actually just one iOS engineer in a separate team. So I don't actually talk to many of the other iOS engineers except during business update meetings and team building events in the evening. So when you're talking about an app that's been around for 5 years and started off as Objective-C, obviously a few pain points are going to start coming up. The first one obviously is a very large code base. There is tons upon tons of files in there. A lot of them are still Objective-C. We are suffering somewhat greatly from, I think Sam did a really good presentation earlier about the massive view controller problems. Most of our view controllers have over 3,000 lines of code, which is like, if you need to find one method, that can take up to a minute sometimes. We're also in an interesting position now because we have a mixing Objective-C and Swift. We have some pretty slow build times. This is getting better, but initially we had 0 unit tests. I'm sure it's a really good thing to say when a company has that many downloads. And because I'm thinking this is more of a sort of a side effect of when a startup goes from initial concept to MVP. A lot of the code there was kind of like not considered originally. So we have a lot of spaghetti code and a lot of like singletons and things like that, like tapping into objects. So we've got a lot of spaghetti code going on. So what am I going to talk about? Here's the Anvil animation. So we're doing a complete re-architecture right now. We're not going to completely kill the code base and do a rewrite. We're going to re-architect it and while keeping it in production, basically rewrite the whole thing. And here's how we're planning to do it. So the first one is we've got this giant mishmash of Objective-C and Swift right now. So
We're going to pick one language. Is anyone got to fathom a guess what language we're probably going to pick?
Objective-C.
Objective-C. JavaScript. I don't know. Well, Mercari US is using a bit of JavaScript from what I hear, so it's not a bad answer. But we're going fully with Swift. And I guess, obvious reasons. Swift is the language of the future, and the company is fully on board with that. Like, I've heard a lot of mixed opinions. Like, some people say it's too early. Some people saying, like, you should have gone earlier. I've heard a few horror stories from companies who started off writing apps in Swift 1 and then had to do lots of, like, technical debt, like upgrading across the versions. But I think we're in a good position now to fully commit to Swift. And once Swift 5 comes out next year, I think that'll be the best turning point for when we can actually start seriously considering ditching Objective-C. And yeah, so the important thing right now is, even if Objective-C is a nicer language objectively, opinion-wise, it is, for all intents and purposes, technical debt at this point. So yeah, Swift is where it's coming from. And because it's Objective-C and Swift, calling Objective-C code from Swift is fine, but calling Swift code from Objective-C can be very, very sad, because suddenly you lose all the Swiftiness that makes Swift Swift. That came out funny. And yeah, basically this means that we now have a problem where we have to write like a bunch of wrappers so we can call Swift code from Objective-C classes. And that just means a lot of boilerplate code and a lot of messy, like, again, more spaghetti code. Swift is objectively a lot easier and faster to write as well, which is great. Like, some things in Objective-C are just, like, even just things like overriding accessors take so much time in Objective-C. This just speeds up development a lot. And at this point in time writing, I checked, we're over at 60% Swift, but there's still a little bit of Objective-C left. But the goal is 100% for all first-party code. So the first order of business was, how do we get rid of the massive view controllers? Sam mentioned a really good paradigm earlier, was a model view presenter, which is really good. But we're actually using the model view model, which is another one quite similar. But I think the role of the presenter is actually just a little bit more generic in this case. But the idea is basically, and this is a really good diagram from a book that the Objective-C IO guys wrote called App Architecture, where a view model basically brings out all the responsibility from a view controller and puts it in a separate object. Now sometimes that just means you're moving all your massive view controller code to another object, in which case you can break it up further, but for the most part that means now you've actually separated your logic out, modularized it. That makes it a lot easier to test. It also means the view controller is now like a dumb pipe for just receiving delegate events. It's kind of like a streamlined view managing class, which I guess is the whole point of a view controller. And how we actually set up our logic is we have a protocol for input and outputs. We specifically streamline and control what data goes into the view model and what comes out. And yeah, the view controller is a pipeline. And if it does get too big, I mean, when I write my own apps, what I like to do is I like to sometimes have a dedicated object for things like, if the table view or collection view is the main point of interaction on a view controller, I'll make that a separate object as well. And yeah, but the great thing about this is it's easy to unit test. So once you've gone from the massive view control problem to this, you can then start realistically making reliable tests for the whole system. But when you and this is coming from the Objective-C IO's, the book's called App Architecture, by the way. I really recommend it. When you basically move that logic out of the view controller, suddenly you're stuck with this mechanism where you now have to bind or like just create scaffolding code to bring all those whenever the view model changes its state back into the view controller. And there's a lot of ways you can actually observe this. You can do things like manual method calling or like delegates. You can in Swift, it's a lot easier. You can say like Swift, object.didSet, things like that. So you can actually just hook when a property changes. One kind of huge, heavy solution is to use Notification Center to broadcast when things change. And maybe depending on where in your app this sort of object lives, that might be a viable solution. KVO is another one, and I was actually researching this recently because Facebook make a really nice KVO controller class that lets you basically just treat KVO like it's a block and that's it. So it's a really easy way to quickly bind like properties to like UI elements and delegates. And this is one I usually do a lot. I just write like handler blocks. Like so my view models are just like a bunch of like state did change with the view handler and like just saying what changed. But that again is a lot of manual code. A lot of these are just manual code. So we jumped on board really, really heavily to a really cool paradigm. It's a bit unconventional by iOS standards, but that's ReactiveCocoa. Has anyone here tried ReactiveCocoa before? I know you have. Is that like one or two hands? Okay, there's a few, cool. Okay, so ReactiveCocoa, for people who don't know, it's a library on GitHub, and it basically subscribes to the concept of functional reactive programming. Basically what that means is you are treating objects and data like a stream of signals. So basically, data is just being emitted from certain objects, and other objects can then like tap into that and respond. It's pretty hard to explain, actually. And basically, why that's really cool is because these guys have done some great things. We can basically have like a property, and you can directly bind that to a UI element. For example, like an email text field in the UI, and you can have an email text value string, just a string property. You can directly, with one line of code, bind that to that field. So whenever that property changes in the text field or changes in the view model, they'll both just keep each other in sync. So the dream here basically is this makes it incredibly easy to have like really tight coupling, but at the same time it's still sufficiently generic and without having a lot of boilerplate code. So basically, how we usually how we do it is we usually have inputs as methods, just basically saying like, you know, this happened in the view controller, and then the outputs are just usually reactive properties. So you can basically register that whenever these properties change, you'll be notified, and you can then update your UI. So that was the first bit. The second bit was this is very interesting. This is an interesting paradigm. I'm curious if it's not being done because of reasons we haven't found out yet, or maybe it's just a really unconventional thing. But basically, we hit this point in the app a while ago where we're looking at this is called the item detail view controller. This is just showing like if you want to buy a copy of Super Mario Brothers for the Wii, all the information about the product. But as you can basically see, it's a table view, but there's a lot of content in there. And the problem is, every single row is different. So once that happens, we kind of like lose all the advantages of UI table view, because now the recycling mechanism makes no sense, because we're not using it, because every time we bring out a cell, it's already in memory, it's already there. But the problem is we actually started to run into like UI table view legacy problems. Like, for example, we had an instance where one of these rows had a text field in it, and we were using ReactiveCocoa to, when you change the text field, it would make another label appear. But there's no way to like, it's a lot more elegant to just say reload the cell as opposed to target the view inside the cell. But in doing so, when you reload a cell, that resigns the text field responder. So suddenly we ran into a bug where a user would update the label, update a text field, and then the label would cause the keyboard to go away, which is a really bad usability issue. So we were like, we're putting up with all the legacy problems of UI table view, but not getting any of the sweet advantages from it, because no recycling and no reordering, things like that. And again, because we were like managing an entire list of, you know, every single index path.row in one giant view controller, again, this was contributing massively to massive view controllers. So we had this idea, or apparently Matt suggested it to us at some point. Well, apparently Dave DeLong suggested it to him, so apparently this may have come from someone who used to work at Apple. What if we just take out the table view, put in a scroll view, put a stack view inside the scroll view, and then make each row in the stack, each row just a static cell, a static view, because that way we can control it explicitly. And the nice thing is UI stack view allows for like automatic content sizing, so we can get UI stack view to work out how big the scroll view is, and then just shunt that to the scroll view. So now we have UI table view like behavior. And this way we actually have explicit control, and we can, you know, we can actually like do a lot more thorough binding, because now we haven't got that table view abstraction over the top of us. Of course, there might be some downsides. Like if it's obviously a very big one where cell recycling might be an advantage, that's good. But in this case, yeah, this is really good. But why stop there, we thought? So the concept here is we've come up with this called micro view controllers. And so instead of every row being a view, it's actually a view controller. So this is an example of our breakdown. Every single row, this is a separate view by the way, but it's the same concept. Every single row is a view controller. And why is that interesting is because we can pass the view model to each row, so we can just pass a state. Every object is still in sync. It allows for much more code separation. But because when we add these view controllers to the parent view controller, they then behave like they're the parent view controller. So you can get things like view did load and view will appear. Like all the system state notifications come down individually. So what we've got here is a super modular implementation where we can actually separate out all the code into their own separate little worlds. And they can still pass state up and down through the view model, but basically this means that instead of having like one massive view controller, now we have like 30 tiny view controllers. Take that as you will. Okay, but the next problem is singletons. So we used a lot of singletons in the app, because there's a lot of things in singletons where they make sense. You want one object in your app, and you don't want any, and you don't want to have multiple objects. Things like API client objects, or things like image caching. Like these are things that make sense to only have one of in your app. The problem is singletons are kind of a really bad solution to this, and I'm going to go through why. It's a reasonable pattern, but it's a bad solution because some should have one instance. Oh, this is everything I just said. The other problem is when you use a singleton, basically you're not really explicitly stating what inputs a class needs for it to function properly. Suddenly you've got this object that takes a few parameters, but then suddenly it just magically goes and reaches off to the side and pulls this thing in. So for things like unit testing, this is like the absolute bane of that, because suddenly you have this implicit dependency that you can't even see from the outside, but it has to be there. And so the solution to this is something called dependency injection that we really like. And I stayed away from dependency injection for a long time because I had no idea what that meant and it sounded scary. But then this guy called James Shaw made a great quote a few years ago saying, it's a $25 term for a 5-step concept. And basically all it is it's basically instead of it being this object that's like instantiated once in global scope, you just make it a parameter of your class. And so you could even just keep it in the global scope, but just when you create this class, you make it a property that you then put in either an instantiation time or just make it a property that you can inject afterwards. The point is you're explicitly marking that yes, when you make this class, you need this object for it to work properly. And yeah, so basically that means that now you have a class that is very testable because you know exactly what needs to come in, exactly what goes out, and there's no magical like side objects. And a really nice thing about this is, again, when you're doing tests, like the greatest example for this is like doing API clients. Sometimes if you don't have network or you just want to do a test, you can then you can yank out the real object, use a mock object, so you can then actually start simulating these requests through testing or even just locally when in debug mode. That becomes much more possible when you're using dependency injection versus actual singletons. Yep. And that just means you've now more explicitly made this visible. So how do we do it at Mercari? Basically, so how we do it is we actually have created a protocol called instantiatable. Like a few people are like instantiable, and it's like, no, it's instantiatable. No, that's totally a word. Let me check the dictionary. Oh, it is a word. Okay. Instantiatable. And basically what that means is that every time we have an object that belongs to this view controller chain, from the top to the bottom, we have this object called an environment. We have a protocol called environment provider, but the object is called environment. And basically, this is a singleton, like we have environment.shared, so it still is a singleton. But basically what this means is that when we create an object, we pass it in as a parameter from the top level object, and then when each of these objects then, this child object is then created, the parent object can then pass this object down. So we're still getting that singleton-like behavior, but we have this incredibly controlled, streamlined way of making sure that from the top to the bottom, you can have this global object that handles all these global mechanisms, but in a very, very explicit way. And at the same time, we actually have several versions of this environment object. We have a production one, a debug one, even a testing one. So we can just swap it out and like attach to different testing servers and production servers. So it's really, really nice. We can just do this. That being said, we have a few, that's one way of doing it, but some people have said to me like in passing that can be kind of complicated because now suddenly you have this giant chain you have to rely on. So one thing that's kind of coming into color really recently, which is kind of cool, is this concept of dependency manager frameworks. So these are frameworks that, the way I understand it, they use like loose coupling and they use dynamic caching to like when you need a dependency, it can work out how to get to it and how to reconcile the one that you need. It's pretty crazy, but I'm told that I actually tried it myself, but I'm told that it's really, really good if you do want to go with the dependency routing injection route. And I have a friend in Japan who like just went from a whole singleton pattern to he used .NET though to fully a similar dependency injection method, and he said that fixed up all of his unit tests and the majority of his bugs went away. So he definitely said this is a good way of going. The most popular one is actually written by my former boss at Mercari, Yoichi-san. It's called Swinject. So I definitely recommend checking that one out if you haven't seen it already. The last one is reducing build times. So the problem with build times is Swift is a very conservative language. Like if you go and watch all the WWDC videos, like Apple actually go on record saying like, due to things like type inference and the likes, compared to Objective-C, Swift is a lot more like, I'm not sure what changed, so I might as well just do a full rebuild just to be on the safe side. And the problem is this can add up, and it means that for the most part, it's pretty slow. That being said, it's getting better and better, like Xcode 10, especially now Xcode 10 has that parallelized builds feature. I think it's getting a lot better. But the way we're trying to fix this at the moment is we have a lot of code that just does not talk to each other. Like we have completely separate sections, like some features are completely isolated. And so how we're going to do this is what we're working on right now is to just break the app out into as many dynamic frameworks as we can. So the idea is like things like purchasing is different from, we have like a live streaming feature and things like that. And the idea is we'll break those out. We have a few common sections that everything uses. So we put that in a framework called Mercari Kit. And below it is Mercari Entity, which is where like data objects, like all the data handling is kept. And the idea is these can be separated out. And so they can be done dynamically during testing for really quick, like not having to like recompile it every time. But then when we actually go do a full deploy, we can then statically link it so you don't get that offset, that downside of dynamic linking where it causes the app to boot slower. And so how are we managing this? So this is interesting because we're a big team and this is happening while we're still shipping the app and shipping features. And so this is interesting juggling going on at the moment. So basically what's going on is, like I said earlier, we are in separate teams. I'm in one specific team. There's another one called the UX team who actually create new features for the payment process and listing items. And so for us, who are actually like working on the forefront, making new features, we are now subscribing to these guidelines and moving forward, working with our code with this in mind. But actually managing this process, we have a dedicated team, kind of like a Black Ops team, I guess, called the Rearchitecture team, whose goal is to come up with these architectures, test them, prove they're viable, and then actually go forward and work on this thing. So the Rearchitecture team is going through all the hideously old Objective-C at the moment, and going through and saying, like, this can be changed, and going through and actually, while preserving the front-facing UI, like completely re-architecting it, or more or less rewriting it in Swift, and then like re-bringing it back in. The problem is that's obviously a bit risky, especially when it's a production app with lots and lots of users. So what we're actually doing on top of that is while we are rewriting new copies of the old UI, we are keeping the old UI and all the features in place and then doing A/B testing where we can periodically turn it on for some users, see and then check the analytics to see if the analytics change. Suddenly maybe all the users stop using that section of the app, which proves maybe something was wrong, in which case, without having to submit a new review to the App Store, we can just say, okay, no, put the old one back for now. We'll go back to the drawing board, see what happened. Was there an issue? Was there a bug? Or was something that's not working? And we can use this way to basically go back and forward to gradually like bring out new parts of the app, but still preserve the experience for the current users and making sure that nothing is a detriment. Anyway, so that's everything. Thank you so much for listening. A quick note, we are hiring, but I'm going to be talking more about that at the dinner tonight. But in any case, thank you so much for watching. I hope you learned something, and I hope you have a great dev world.